Okay, kids, we're winding down here, but I know some of you are going to be taking physics next year. So if you're taking physics, it's a science that has a lot of math in it. So we're kind of going back a few sections here and reviewing some of the calculations today and then a different calculation tomorrow. Just want to make sure that when you step into a physics class, you have an idea of how this works. So we're going to go back and look at index of refraction. And the index of refraction is a property, a characteristic of a material that describes how quickly light travels through this transparent material compared to how quickly light travels through emptiness. And there was an equation associated with it. N, the index of refraction of that material, that property of a material, is equal to C. Now, C is the speed of light in emptiness, which is 3.0 times 10 to the 8 meters per second, or 300 million meters per second. There's nothing faster than it in the universe. And v is the speed of light in the particular material we're looking at. So we have this equation here. Now the equation can be converted into a triangle like this. So for example, if they don't ask you to calculate for n, let's say they ask you to calculate for the speed of light in that material, and you're given the index of refraction, you just look, you cover up the v, and the equation becomes c over n. So these triangles are pretty useful. And from the textbook, I've got various index of refraction for different materials, and you can see them here. Diamond's kind of big, water near the smaller end of things. So light would travel very slowly in diamond. It would slow down compared to air in water, but not as much of a slowdown. So here's an example question. Let's do this example question. There is a type of glass where the speed of light is 1.7 times 10 to the 8 meters per second. What is the index of refraction of this glass? Oh, I've got to put a question mark in there. That's better. And, well, you use the equation. You put in the numbers, 3.0 times 10 to the 8 meters per second. You put in the speed of light in that glass. So we're just following the equation. Index of refraction is equal to speed of light in emptiness, or vacuum, divided by speed of light in the material we're interested in investigating. And you do your dividing and you get 1.8. So that would be the index of refraction for this particular type of glass. And there's many different types of glass. Here is the other type of calculation I was talking about, where we want to find the speed of light in a material. So we cover up the v and look at the equation that's left, c over n. So we put that speed of light in the material is equal to speed of light in vacuum over the index of refraction of that material. So we put in the speed of light here in emptiness, there it is, and the index of refraction for diamond is in the table that we looked up a few minutes ago. We do our dividing, and there we have it. The speed of light in diamond, 1.24 times 10 to the 8 meters per second. It's slowed down by more than half. That's what makes the diamond all sparkly and everything. So, as I said, if you're going into physics today and tomorrow, I'm going to kind of give you a brief look at some of these calculations. Tomorrow's calculation will be more mathematical, but we'll get it together. Don't you worry. Have a great day. Bye-bye.